So welcome to Pure 2, Chapter 5. In this chapter, we'll be looking into radians. So what's radians? Well, obviously, I will tell you today's lesson about 5.1, which is about introduction to radians. And then in the rest of the other section, other videos, we'll be looking at arc length and how we can use radians to solve trick equations, which require your Chapter 10 knowledge in Pure 1 and small angle approximation, a really small niche topic that you need to know that comes up in exam nearly every single year. Before we kickstart, I cannot help but to mention this little cake in here. This cake was made by one of my students a long time ago, which is actually, it looks small, but actually it's huge. It's huge enough to share between 20 to 30 people. And obviously, that's a student that actually made it for the Pi Day because she was a year 11 student. Back in GCSE, you don't learn any radians. So this is about Pi Day. But we know pi and radians go hand in hand. Whether you know it or not, radian is about pi. Okay, so anyway, it actually tastes good, by the way. So kudos to her. Just thank you. Right, so 5.1 about radian. So what's a radian? And a radian is another measure of size of angles, alternative to degrees. If you think about similar to temperature, in temperature we have Celsius, we have Fahrenheit, we have Kelvin if you do science. Do they measure the same temperature? Yes, they do, but they just present a different way. For example, if you go out, if you're really cold, in degrees Celsius, that will be, because I always use Celsius, I don't know Fahrenheit, but let's say Celsius will be 2 degrees, 3 degrees, but in Fahrenheit could be, I actually don't know what's 2 degrees equivalent to Fahrenheit. Let me do a bit of Googling. Give me a sec. Okay, so 2 degrees Celsius is the same as 35.6 Fahrenheit. So 36. So you can see, you know, whether you tell people it's 2 degrees Celsius or 35, 36 Fahrenheit, people will feel, oh, it's cold. When you tell people, same with angles, we have degrees and we have radians. They just measure differently, but do they talk about the same angle? Yes, they do. Okay, but just different presentation. So a degree is a 3/60th of a rotation around a full circle. Oh, really confusing. What does that mean? What it means is, so if we use this circle for degree, it means we divide the whole circumference by 360 slices. I'll put a bracket slices because I like to use cake to talk about circumference. Think about a cake. Don't judge on my favorite cake. My favorite cake, I'm an old soul. I actually like coffee and walnut cake. Yes, don't judge. But if you have it divided by 360 slices, then that slice that each person get is called 1 degree. Okay. Now on radian, 1 radian, however, is the movement of one radius worth around the circumference of a circle. Very confusing, isn't it? So what it means is we divide the whole circumference by radius, by one radius. Okay, by the radius. That means the bigger the circle, then the bigger the circumference, but also the bigger the radius. So the radian will still be consistent in that way. So yeah, it's a different way of measuring, just remember radian. So don't understand? We'll look into a bit more details. Now, here's a full circle, right? You can see a green circle. There's a radius. Now you can see this green line is a radius. Now around the circle, we see broken into six parts because each part is also radius. So roughly, now it's not exactly the same, but it's roughly, we can see one circle of angle is roughly equals to 6 radians. So if you have a bigger circle, okay, that's a radius. Okay, that's a radius. If you divide the whole circumference by radius, so imagine that length, that's 1, 2, 3, 4, 5, 6. That's very roughly. I know they're not very consistent, but to show you, it's roughly 6 radians. It's not exactly 6. Okay, that's why we're doing a bit of experiment investigation here. If we change it degrees, that's 360 degree is roughly 6 radians. But this is only a rough estimate. So there's a rough estimate. It's not accurate at all. So what can we do to work out the conversion between degrees and radians? Right, so here we go. We know the circumference is 2 pi r, right? So we know circumference 2 pi r. We are thinking about how many radii, plural of radius, can we fit into a full circumference? So full circumference 2 pi r. Radii means we divide by r equals to 2 pi. That means we can fit. That means we can fit 2 pi lots of radii into circumference. So what does that mean? That means 360° equals 2 pi. So 360° equals 2 pi because we can fit 2 pi lots of 360°. So therefore, okay, so therefore, 2 pi, if you put in calculator, 2 pi, 2 times 3.14-ish. Yeah, don't start me off with decimals because if we do that, I don't know how long this video will continue. It actually probably endless. It's going to be a endless length of video. So full circle is 2 pi radians. We use reds for radians. Full circle is 2 pi. If you don't understand what's going on in here, don't worry about that. What you have to remember is full circle is 2 pi radians. So conversion between degree and radians, what you have to remember is that 360° equals 2 pi reds. Right? Some people like to use a small r on the top, so maybe 2 pi reds like this. Also works. Okay. So 180° equals pi, 1 pi reds. So remember that. Okay. So remember this ratio. 180° equals 1 pi. And so degrees to radius is that 180° equals to pi. And 360 equals 2 pi. So if you do really want a shortcut, okay, so or alternatively, because there's one way to remember, whichever way works for you to remember, you can remember that way. So to do from degree to radians, if you want to go from degree to radians, you divide by 360 and times it by pi. If you go from radians to degrees, divide by pi times 3. Oh, not sorry, divide by 180. My bad. And this one is 180. Okay, so well, that's it really. Okay, so remember that. Okay, remember these two. There are two ways to remember it. Okay, right. So arc length. What about arc length? Now you've learned in GCSE arc length. In arc length in GCSE, you have learned 2 pi r. Oops. 2 pi r, the circumference, times theta over 360°. That's what you've learned about arc length, right? But in radians, we know 360 since 360° equals 2 pi. Therefore, arc length equals to 2 pi r times theta over 2 pi. You can see I just replaced 360 by 2 pi. And then if I cancel out 2 pi in numerator, denominator, you will see, oops, mouse not working. What is it? Yep. So arc length equals to r theta. So that's arc length in radians form. Okay. And you will have to remember that in radians form. R theta, they're not given in formula booklet. Okay. Radians. And theta, this theta is in radians. Radians. Okay. Let's carry on. So before we actually do any arc length, any kind of, sort of stuff, we go back to basic about converting degree into radian or radian to degree. You can easily tell which one's radian, which is degree. Degree usually quite a big number, 90°, 135, 60°. You rarely see 1 degree, 2 degree, right? So, but in radians, you'll see really small numbers, 0.34, 3.12, 2.45 radians, or more commonly in terms of pi, pi over 3, 3 pi over 2. So to convert 90° into radians, now we know 180° is pi. So 90° is pi over 2. Or if you really want to do some maths, 180° equals pi. How do you work out 90°? Divide by 2 on both sides. Okay, that's pi over 2. 135°. Okay, 135°. To convert from degrees to radian. So degrees to radians, divide by 180 times it by pi. So put in a calculator. So simply do 135 divided by 180 times it by pi. Put in a calculator. 3 over 4 pi. So 3 over 4 pi. Okay, what about pi over 3? To convert radians to degrees, we times it by 180. So pi over 3 times it by 180 divided by pi times by 180 degree. Or, sorry, actually you don't need degree, divided by pi. So put in a calculator. Pi over 3 times it by 180 divided by pi. 60. Okay, 3 pi over 2, do the same thing. 3 pi over 2 times 180 divided by pi. And you should get 270 degree. Okay. Is it? Pi over 2, 90. Here, 9. Pi over 2 is 90 degree. 90 degree times 3 is 270 degree. Okay. So practice. Question 1. Pause video. Have a go. Okay. When you're ready, press play. Here's the final answer. Okay. So A divided by 180 times pi over 4. 2 pi over 5 divided by 180 times pi. For C, to change radians to degree, times it by pi. Times it by 180 divided by pi. And you get these answers. All right. Or just remember, pi is 180 degree. So part C, pi is 180, 180 divided by 6, 30. Part D, 7 times 180 divided by 5, 252. Okay, that's a quicker way. Oh yeah, I should write it down as well. Part C, you can do, or you can do, alternatively, you can do 180 degree divided by 3, which is 6 degree. Okay, but we know pi is 180 degree, so you can substitute pi is 180 degree in part C, part D previously. Right, example, using a calculator. So time to pull out a calculator. So first of all, to change the degrees, actually, I'm already in radians mode. If you look at top, the display, the top part, you will see yours one should be D, means degree, if you haven't used radians mode before. Okay, so what you can do is to change in radians mode, you would press Shift menu. Okay, then in here, or different calculator, different kind of configuration, just find the one where it says setup, because Shift menu gives you setup. It's usually around there. Then play around with, you should see an angle unit. They'll ask you degree, radian, or gradient. I didn't actually know what a gradient is. I don't think I've used it or seen it before. So anyway, radian. Once you press 2, you see the top says radian. Now be very careful whether calculate in radians mode or in degrees mode, because it'll give you a totally different answer. So for example, in here, work out sine 0.3 radians. So my calculation in radians mode, sine 0.3 equal, just equal, we're giving 3 SF. So 0. Maybe 4 decimal places, 0.2955. So 0.2955. Simple. It's as simple as this. Okay. Maybe you can have a go at part B and part C. So you should get cos pi minus 1. 10 to pi. 10 to pi. 0. Okay. Now, what if we do the same thing, this time degrees? You will see a massive difference. So let's try this. Shift menu. Let me change it back to degree mode. Okay. Now, in degree mode, let's do 10 to pi. 10 to pi. You can see the answer is totally different. Well, you may say, oh, 0.11 and 0 is close. Okay, let's try the other one. Sine 0.3. We're saying 0.3 degrees. Okay, that's how small it is. 0.3 degree. That's a very, very small slice. You can see 5.22 times 10 to the power minus 3. That's a very, very different number to 0.2955. So if a calculator, the question from now on could either use degree or radians. So make sure you read carefully and change your calculator settings accordingly. Okay, so we're in radians. Let me change back to radians before I regret. Okay, so sine 0.3, 0.255. Okay, right, graph sketching. What about graphs? So we'll do sine graph and cos graph. So hopefully you do remember the sine graph and cos graph of the normal degrees. Okay. So for sine graph, we know it is simply like this. Okay, so that's y, that's x, and we know that's 1, that's minus 1. In terms of angle, we normally have 90 degree in here, we write pi over 2. That's pi, that's 3 pi over 2, and that's 2 pi. What about cos graph? Cos graph like this. Okay, same thing, 1, minus 1. Normally 90 degree, 90 is pi over 2. Normally 180, pi, 3 pi over 2 for 270, and that's 2 pi for 360 degree. Okay, and that's y equals cos x and y equals sine x. Okay, so example in here. Sketch a graph of y equal cos x plus pi for x between 0 and 2 pi. That's the same as between 0 and 360 degree. Okay, so by the way, if you know these answers, you can have a go at a question and check it with me at the end. All right, but if you don't, I'll explain it. X plus pi. This is a translation. Or actually, yeah, translation. Or simply, I like to use the word move. So we're moving to the left, moving left by pi, because x plus, so think about f of x plus pi, or f of x plus 2. X plus 2 means we move left by 2. X plus pi means we move to the left by pi. So it's just a transformation of graph that you've learned in year 1. So we know the cos x graph normally looks like this. When we have to move to the left by pi, means this pi value will now be at 0. Okay, so how it looks like is this. Let me sketch the axes. Okay, so this point that was at pi, if we move to left by pi, is now at 0. So it goes like this. That's -1. That's 1. That's pi over 2. That's pi. So where it was 2 pi, now it becomes here. The peak at 2 pi, now the peak is at pi. 3 pi over 2 and 2 pi, x and y. That's it. All right, and that's 5.1. So we learn about the conversion between pi, radians, and degrees.